Welcome friends, in this new video we will derive Gauss central backward interpolation formula, central difference backward interpolation formula. We consider the function y equal to f of x. Of the arguments are u at -3, -2, -1, 0, 1, 2, 3 dash dash dash, and value of the function corresponding to these values are -3, -2, -1, y at 0, y at 1, y2 and y3, like this. So these are the values. Remember once again the Newton's advancing difference formula. Newton's advancing difference formula. This is required to derive the formula, differencing formula, and it is very simple. Yu equal to y0 plus uc1 delta y0 plus uc2 delta square y0 plus uc3 delta cube y0 plus uc4 delta raised to 4 y0 plus plus plus. Now the delta y0 equal to here let us apply the delta y0 means y 0 plus 1 minus y0. This is the formula for delta y0. So we get y at 1 minus y0, y1 minus y0. Then delta square y minus 1, this will be delta of delta y at minus 1 equal to delta of y minus 1, addition of this one. So y0 minus y at minus 1, this is equal to delta at y0 minus delta at y minus 1. So transfer this value to left side and let us deduce this delta y0. Delta y0 equal to delta y at minus 1 plus delta square at minus 1. Similarly, delta cube at minus 1 equal to delta square of delta at minus 1 equal to delta square. Delta means y delta square at 0 minus y at minus 1. Now this is a delta square, delta cube at minus 1 equal to delta square y0 minus delta square at minus 1. This implies delta square at y0 equal to delta square at minus 1 plus delta cube at minus 1. Now let us put these values in this equation. If we put these values, y at u equal to y0 plus uc1 into delta y0, this value delta at y0 equal to delta at y minus 1 plus delta square at y minus 1 plus uc2 delta square at y0. So this is delta square y minus 1 plus delta cube at y minus 1 plus uc3 delta cube. Similarly, delta cube at y minus 1 plus delta raised to 4 at y minus 1 plus plus plus. So if we put these values, y0 plus uc1 delta at y minus 1 plus uc1 delta square at y minus 1 plus uc2 delta square at y minus 1. Let us see the values. Equal to y0 plus uc1 delta y at minus 1 plus delta square. So we take delta square y at minus 1 common and uc1 plus uc2 delta square y at minus 1 plus this uc2 delta cube y at minus 1 plus uc3 delta cube y at minus 1 plus uc3 delta raised to 4 y at minus 1 plus equal to y0 plus uc1 delta at y at minus 1 plus here u plus 1 c2 delta square y at minus 1 plus uc2, let us put the value of delta cube from this, delta cube y at minus 2 plus delta raised to 4 y at minus 2 plus uc3 delta cube y at minus 2 plus delta raised to 4 y at minus 2 plus uc3 delta raised to 4, so delta raised to 4 y at minus 2 plus delta raised to 5 y at minus 2 plus. This is e y0 plus uc1 delta at minus 1 plus u plus 1 c2 delta square y at minus 1 plus delta cube y at minus 1 delta cube y at minus 2, so uc2 plus uc3 delta cube y at minus 2 plus uc2 and here uc2 plus uc3 plus this uc3 again we substitute one more times delta raised to 4 y at minus 2. Okay, then we see that this value equal to y0 plus uc1 delta at minus 1 plus u plus 1 c2 delta square y at minus 1, so y0 then 2 times y at minus 1 plus, now next y at minus 2 terms of y at minus 2, so this will be u plus 1 c3 delta cube y at minus 2. Next term will also from this y at minus 2. Now this u plus 1, the next one will be u plus 2 c4 y4 at minus 2 plus like this. So this is at yu and this is known as Gauss central difference backward formula. This is known as Gauss central difference backward formula. So there is a not a lot of difference between the derivation of Gauss as forward and Gauss backward difference formula. We have to put very carefully the values of delta 0 in the Newton's advancing difference formula. By careful substitution we can derive easily the Gauss central forward difference formula and Gauss central difference backward formula. Thank you friend, thank you for watching this.